Alright, we'll start off from where we left off, which is problem 3 is where we'll start from, but let me go ahead and zoom in a little bit so that we can see it a little better. That's 3, so let's... Alright, so this is where we'll start with just a little more. Okay. So this one tells you, let's read the problem together. An investment of 10,000 is compounded continuously. So I'm starting off with 10,000, that means this is my P. And then it says what annual percentage rate will produce, that means R is what I don't know, R is what I'm trying to find. Another key thing we forgot to underline, compounded continuously, compounded continuously. So when we're talking about compounded continuously, the formula that we'll use is A equals P E raised to the power of RT. This is the compounding continuously formula. And produce a balance of 25,000, that is the final amount, which is A in 10 years. This is your T. So let's substitute and solve for that rate. So A is 25,000. P is I'm starting with 10,000 times E is a constant. Rate is what I don't know, and T is 10. So here what do you have? You have an exponential equation. Why is it an exponential equation? Because there's a variable in the exponent. So you have to basically try to get to that R. First thing is I'll get rid of this 10,000 so that E is by itself. So when you divide both sides by 10,000, I am left with 2.5 equals E to the power of 10R. Now what do I do? Step 1, step 2. For you to get to the R, remember how do you solve an exponential equation? If you cannot get the same base, you basically take ln on both sides, or log or ln. I'll go ahead and take ln. So ln of 2.5 equals ln of E 10R. And ln of E will cancel each other just to give you 10R. So ln of 2.5 equals 10R, because remember ln and E are opposites of each other, they have the same base. So which basically means R equals ln of 2.5 over 10. It's easy to put this in your calculator. You will get something like 0.0916. But you want to represent this as percentage basically will mean 9.16%. Okay, so that's that problem. So you're basically using the compounded continuously formula. Okay, I'm going to keep going. This one says Jane has just inherited a diamond ring appraised at $7,000. So let's see, is this my starting amount or the final amount? If diamonds have appreciated in value at an annual rate of, so this one says annual rate. That means when something is annual, something is being calculated annually, that means N equals 1. That means N equals 1. Rate of 8%. That means R equals, you want to put it in decimal, 0.08. What was the value of the ring in 20 years? T equals 20 when it was purchased. So basically they're asking what was the starting value. That means what I'm trying to find the starting value, which is your principal. And what is this? This is A. A is 7,000. A is 7,000. And remember, I'm not doing continuously, so which formula am I using? I'm using this formula. A equals P 1 plus R over N and T. This is the formula that I'll be using. Right, so now let's substitute everything. I know my A to be 7,000. That's my final amount because that's what the value is today. I don't know my principal amount. I said my rate was 0.08. I said my N was 1. I don't even have to write this, but I'm just writing it for now. And then N times T, so 20 times 1 is just 20. How do you get this P by itself? You divide both sides by this amount. So P equals 7,000 divided by 1 plus 0.08, which is 1.08. I don't know why I didn't write that. It's 1.08 raised to the power of 20. Go ahead and put this in your calculator. You should find P to be equal to 1501.84. You just put this in your calculator. You should get that. You should get that. All right, so I'm going to keep going. Just when you're putting in the calculator, just be careful of how you're putting it in the calculator. But it shouldn't be. This one should not have too many parentheses. There's no fraction within a fraction and all of that stuff. All right, let's look at the last problem on this page. It says if you invest $5,000 in stock, so it looks like P is 5,000, and that's what I've written here, at the rate of 4.25. So what's my rate here? Rate is, remember you won't write in decimals, so decimal divide by 100 moves 2 zeros back, 0.0425. That's my rate. Then the value of the stock is given by this. Okay, so here they have actually given us a function that we need to use. They've actually given us a function that they used to, and this is the P, and that's what they've given us here. And 1 plus 0.085, because that's my formula. Remember my formula is 1 plus R, and that's my R. That's my R. So that's the given formula. Okay. So where X is measured in years. So what's my unknown here? X is my unknown here, which is the years. Assuming that the value of your stock continues growing at this exponential rate, how much will your investment be worth in 4 years? That means my X equals 4. So I think this is just a matter of putting this in your formula. So basically, when X is 4, 5,000. I'm just going ahead and doing this formula. It's 5,000. I'm just looking at this. 1.0425 raised to the power of 4. Put this in your calculator and you should get 5905.74. Okay, so all this is just a matter of putting all of this in the calculator. All right. And this one is slightly different. It says here you're calculating the final amount. Here it says when will your investment be worth 14,000. This is your A. When will your investment, so what do I not know? I don't know X, which is the time. It's the X that I don't know. So basically f of X is going to be 14,000. My final amount is 14,000. I'm starting out with 5,000. Now I'm just going to use my formula 1.0425. I'm just going ahead and looking at this formula, and X is my unknown. How are you going to get this X? It's an exponent, right? It's an exponential equation. You want to get that, so you'll convert it into log. But I'll first get rid of this 5,000. So 14,000 divided by 5,000 is 14 divided by 5 equals, so step 1, step 2, 1.0425 raised to the power of X. For me to get X by itself, I take ln on both sides. Ln of 14 over 5 equals X. So when I take ln on this side, X will come to the front, and it's going to be ln of 1.0425. Okay, hopefully you're able to see that. It's just this. It's just from here I'm going here. So X is, so you want to get X by itself, so X is going to be equal to ln of 14 over 5 over ln of 1.0425. And again, it's just a matter of putting this in your calculator. When you put this in the calculator, please be very careful. This has its own parentheses divided by this whole thing will be in its own parentheses. And you should get approximately 24.7. Approximately 20. So they're basically talking about 25 years or 25 years. In 25 years, your 5,000 will grow to 14,000. So you see how these things are. We're using the whole exponential, how to solve an exponential equation in these compound interest formulas. All right, let's go to the next page, and I'll start with the next part 2, which is basically growth and decay. All right, so this one says part 2, and if you look at this particular section, it says the general formula for growth and decay is this. Does it look familiar to you? This is A, the final amount. P, A0, instead of P, because we're not talking in terms of principal, we're talking about A0 is the starting amount. A0 is the starting amount. E raised to the power of what we have seen as RT, but instead of RT, we are saying KT. K is the rate of growth. R is the rate of growth there. So that's what basically we're talking about. So AT is the size of the population. So they're talking about population, but this is not necessarily we're talking about just the population. This particular formula can be used for any growth and decay. And A0 is the original population or the initial amount when t equals to 0. And K is the rate. K is the rate. K and R are the same, rate of growth. And if K is greater than 0, the population growth increases over the time. This is the law of universal growth. Or exponential growth. If K is less than 0, then the population decreases or decays. Alright, so that's what's important. So this, the rate, and the rate is less than 1. So when it's this, you know how the graph looks like, right? You start off really small and it becomes big really quick. And this one is you start off big and then quickly comes down to almost 0. So you have a horizontal asymptote. So this, we have seen these graphs. We have seen these graphs, but now we're going to apply this. Now we're going to apply this to some word problems. Okay, so let's look at this. Let's do, all right, why don't we, now that I've introduced this to you, why don't we stop at this point? Because I was just looking at the length of the video, and then we'll pick it up in the next video.